Standard 12th Maths Chapter 2 Complex Numbers Exercise 2.8 Question number 1. Before start doing the problem, let me give you some introduction. De Moivre's theorem. This theorem states that if a complex number z is expressed in the polar form cos theta plus I sin theta, then the power of z as n, z power n is cos theta plus I sin theta the whole power n. So if the complex number has the index n, it will be bring to the multiple of angle cos n theta plus I sin n theta. I sin n theta. So this is the De Moivre's theorem. Z power n cos theta plus I sin theta the whole power n equal to cos theta plus I sin n theta. Suppose you have the complex number as cos theta minus I sin theta the whole power n. So in that case you will get cos n theta minus I sin n theta. If the power is negative, cos theta plus I sin theta the whole power minus n. So in that case also you will get cos of minus n theta plus I sin of minus n theta. So cos of minus theta is plus cos theta. So cos n theta. Sin of minus n theta. Sin of minus theta is minus sin theta. So sin of minus I sin n theta. So one more formula. Suppose the complex number is of the form sin theta plus I cos theta. So in that we can apply the De Moivre's theorem only for in the form cos theta plus I sin theta. So I replace this as cos of 90 minus theta, that is sin theta, plus I sin of 90 minus theta. So if you have the index as n, so whole power n, so you will get cos of n pi by 2 minus theta plus I sin n pi by 2 minus theta. You will get here n. Okay. Next we will see the cube roots of unity. Cube roots of unity. Suppose z is a complex number is the cube root of unity, that is cube root of 1. So the roots for this complex number is, the roots are 1, omega squared. You have cube root, so 3 roots you will get. So that you will get in the example. See example 232. It is in page 89. You can refer this roots also. So with the condition omega cube is equal to 1 and also 1 plus omega squared is equal to 0. So using this concept we are going to do the first sum in this exercise. See, using this concept we are going to do the first sum in this exercise. See the first sum in the exercise. If omega not equal to 1 is a cube root of unity, show that this fraction plus this fraction is equal to minus 1. See, given here omega is a cube root of unity, that is omega cube is equal to 1. And also one more result we have, 1 plus omega squared is equal to 0. These two we are going to use in this sum. So let me take the left side. The sum of two fractions is equal to minus 1. So take the left hand side. See, the first fraction, in the denominator you keep as it is. b plus c omega plus a omega squared. So numerator term, I'm going to make some change here. See, numerator b omega, but here b alone. So I have to take omega outside. And also one more thing here, a alone here, just I multiply a with 1. I replace this 1 as omega cube. So a omega cube, write the rest as it is, b omega plus c omega squared. In the second fraction also keep the denominator as it is, c plus a omega plus b omega squared. See, numerator also a is alone here, a into 1. I replace 1 as a omega cube. And also see here b omega you have here, but in the denominator we have omega squared. C omega squared, but c alone here. Omega squared should be taken outside. So in that case I multiply this b omega into 1. So this 1 also I replace as omega cube. So b omega power 4. Already one omega here, so omega power 4 plus c omega square. See, just only one concept you have to take, c b omega into 1. The rest in both the fraction, a should be added with omega cube. Now, in the numerator, I have to take here first fraction omega outside. So, you will get a omega squared plus b plus from omega squared c omega. Denominator b plus c omega plus a omega squared plus here c alone here I have to take omega squared outside. So, you will get a omega plus b omega squared plus c divided by c plus a omega plus b omega squared. See, in the first fraction, the bracket terms are same. B plus c omega plus a omega both gets cancelled. So, I get omega plus. The second fraction also bracket terms are same. C plus a omega plus b omega squared. Both the expressions gets cancelled. You will get omega squared. What is here the condition? 1 plus omega squared equals 0. But here we have omega plus omega squared. Take 1 to the other side, you will get minus 1. This is your right hand side result we proved here. That's all. See the second sum. Show that root 3 by 2 plus I by 2 the whole power 5 plus root 3 by 2 minus I by 2 the whole power 5 equal to minus root 3. See these two complex numbers, they are conjugate of each other. Root 3 by 2 plus I by 2. Same term, same root 3 by 2 minus here. So both are conjugate of each other. So first let me take the first number as z, root 3 by 2 plus I by 2. I am going to write this in the polar form so that you can apply the De Moivre's theorem. So this is equal to r cos theta plus I sin theta. So what is r cos theta? This is equal to root 3 by 2. R sin theta is, coefficient of I is here 1 by 2. So what is r here? R is equal to root of x square plus y square, that is root 3 by 2 the whole square plus 1 by 2 the whole square, that is root 3 is squared is 3 by 4 plus 1 by 4. So 4 is the LCM, 3 plus 1 4. So root of 1 is 1 or value is 1. So cos theta, so take the r cos theta, substitute r as 1, so you will get cos theta as root 3 by 2 and substitute r as 1 here, sin theta is equal to 1 by 2. See, both are positive values, so the angles lie in the first quadrant, both values are positive. So for what angle you will get these values? Cos theta value is root 3 by 2. Sin theta value is 1 by 2. So for theta is equal to sin 30 is 1 by 2. Cos 30 is root 3 by 2. So theta is equal to pi by 6. Pi by 6. So therefore the first complex number root 3 by 2 plus I by 2 is equal to, I substitute r as 1 and theta as pi by 6. So cos of pi by 6 plus I sin pi by 6. So its conjugate is root 3 by 2 minus I by 2. That is cos of pi by 6 minus I sin pi by 6. Now come to the problem. Root 3 by 2 plus I by 2 the whole power 5 plus root 3 by 2 minus I by 2 the whole power 5. This is equal to cos pi by 6 plus I sin pi by 6 the whole power 5 plus cos pi by 6 minus I sin pi by 6 the whole power 5. So this is equal to, according to De Morgan's theorem, I bring this index to the multiple of angle here. Cos of 5 pi by 6 plus I sin 5 pi by 6 plus, for this cos 5 pi by 6 minus I sin 5 by pi by 6. So both complex number we are adding. So cos, here cos pi by 6. So 2 times cos of 5 pi by 6. This is plus I sin pi by 6 minus I sin gets cancelled. So but we have to show this is equal to minus root 3. The value is minus root 3. So what I do, I write this cos as here pi by 6, 5 pi by 6. So I write this as pi minus pi by 6. See 6 LCM, 6 pi minus pi is 5 pi by 6. You can write here. So this is equal to here 2 cos of pi minus theta is cos theta, cos pi by 6. But it is in the second quadrant, all silver teacups. So in the second quadrant, only sign is positive, so cos becomes negative here. So minus 2 cos pi by 6. So minus 2 cos pi by 6 value is here root 3 by 2. So 2 cancel, you will get here minus root 3. So this is your right hand side result. Thank you.